Hello everyone. Today I'm going to discuss about the Schrodinger equation for a hydrogen atom. The electron and proton in a hydrogen atom, it interacts through a Coulombic potential, that is V of r is equal to minus e square by 4 pi epsilon naught r, which is the first equation. Here E is the charge of the proton, epsilon naught is the permittivity of the free space, and r is the distance between the electron and proton. Here we are using a spherical coordinate system with a proton at its origin. The term 4 pi epsilon naught arises since we are using the SI units. The Hamiltonian operator for a hydrogen atom is given by h cap is equal to minus h cross square by 2 me del square minus e square by 4 pi epsilon naught r, which is the second equation. Here me is the mass of the electron. Now the Schrodinger equation is given by minus h cross square by 2 me del square psi r theta phi plus v of r psi r theta phi is equal to e psi r theta phi, which is the third equation. Now the Laplacian operator written by del square, it is in the spherical coordinates form. That is del square is equal to 1 by r square dou by dou r into r square by dou r plus 1 by r square sin theta dou by dou theta sin theta dou by dou theta plus 1 by r square sin square theta dou square by dou phi square, which is the fourth equation. Now we are substituting the value of del square into the Schrodinger equation. That will give us the equation 5, that is minus h cross square by 2 me into 1 by r square dou by dou r square dou psi by dou r plus 1 by r square sin theta dou by dou theta into sin theta dou psi by dou theta plus 1 by r square sin square theta into dou square psi by dou phi square plus v of r into psi r theta phi is equal to e psi r theta phi. It is the equation 5. Now in order to bring them to the magnesible forms, we are multiplying the equation 5 with 2 me r square, which gives us equation 6. That is minus h cross square dou by dou r into r square dou psi by dou r minus h cross square 1 by sin theta dou by dou theta sin theta dou psi by dou theta plus 1 by sin square dou square psi by dou phi square plus 2 me r square v of r minus e psi r theta phi is equal to 0. Here in this equation we can see that in the second term it consists of the theta and phi dependencies, so it can be written as L cap square psi. And substituting this, we are writing the seventh equation, which is minus h cross square dou by dou r into r square dou psi by dou r plus L cap square psi plus 2 me r square v of r minus e psi of r theta phi equal to 0. Here the phi and psi factors, it should be in the eigenfunctions of the L cap square, which can be expressed in the terms of the spherical harmonics, that is yl ml theta phi, and thus the equation can be written as L cap square yl ml theta phi is equal to h cross square L plus 1 yl ml theta phi. Here in this equation, instead of J and M, we have written it in terms of L and ML while applying it in the case of the hydrogen atom. Now the value of L can be 0, 1, 2, and it is limited as minus L plus less than or equal to ML, which is less than or equal to plus L. Thus we get psi of r theta phi is equal to r of r yl ml theta phi, which is the equation 9. Now using equation 7 and 8, it becomes minus h cross square by 2 me r square d by dr into r square dr by dr plus h cross square L into L plus 1 by 2 me r square plus v of r minus e into r of r equal to 0. This is the equation 10, which is called as the radial equation for the hydrogen atom. This is the equation which provides the complete solution for the hydrogen atom. Now this equation, it can be physically interpreted as the total energy is the sum of the radial kinetic energy, angular kinetic energy, and the potential energy. So this energy must be quantized as in the case of equation 11, En is equal to minus e raised to 4 minus me e raised to 4 by 8 epsilon naught square h square n square is equal to minus me e raised to 4 by 32 pi square epsilon naught square h square n square, where n is equal to 1 and 2. Now we are introducing the Bohr's radius from a naught, that is equal to e naught epsilon naught h square by pi me e square. By solving we get that En is equal to minus e square by 8 pi epsilon naught a naught n square, where n is equal to 1 and 2. This is equation 12. Now here n should satisfy the condition that n is greater than or equal to L plus 1, which can be written as 0 less than or equal to L, which is less than or equal to n minus 1, where n is equal to 1 and 2. The smallest possible value for L is 0. So the radial wave function, it depends on the two quantum numbers n and L, which is given by the equation RNL of R is equal to minus of n minus L minus 1 factorial by 2n into n plus 1 factorial whole cube whole raised to 1 by 2 into 2na naught raised to L plus 3 by 2 by into RLE minus R by NA naught into L n plus 1 power 2 L plus 1 into 2R by NA naught. Here we are to introduce a new term, that is n plus L raised to 2L plus 1 polynomials. They are called the Laguerre polynomials. The radial wave functions given by this equation, though they look complicated, it can be noted that in each one there is a polynomial multiplied by the exponential. So the combinational factor in front assures that RNLR, it is neutralized with respect to the integration over R, or that RLN NLR, it satisfies the given equation 15, that is integral 0 to infinity dr r square r star NLR RNLR is equal to 1, where the r square dr, it is the volume element in which r is the part of the spherical coordinate volume element r square sine theta dr d theta d phi. Now the complete hydrogen atomic wave function is given by the following equation, that is xi nl ml r theta psi is equal to RNL of r into yl ml theta phi. The normalization condition for the hydrogen atomic wave function is integral 0 to pi d theta sine theta into integral 0 to 2 pi d phi into integral 0 to infinity dr r square infinity psi star nl ml into r theta phi of psi nl ml of r theta phi is equal to 1. Here h cap is the Hermitian and the function of psi nl ml must be orthogonal. So the orthogonality relationship, it is given by the equation 17, represented as integral 0 to 2 pi d phi integral 0 to pi d theta sine theta into d integral 0 to infinity dr r square psi star nl ml of r theta phi into psi n l ml of r theta phi is equal to del n n dash del l l dash del ml ml dash. That is, here this del term, it is known as the Kroneker's delta, and it is del ij is equal to 0 when I is not equal to j, and del ij is equal to 1 when I is equal to j. Now this equation 17, it can be represented in the bracket notation as NL ML by N dash L dash ML dash is equal to del NN dash del LL dash and del ML ML dash. It is equation 18. the psi NL ML R theta phi N ln L ML depends upon the three quantum numbers, which are these functions will be simultaneous eigen functions of h cap, L cap square, Lz cap, which will mutually commute. That is, h cap L cap square is equal to h cap Lz cap is equal to L cap square Lz cap is equal to 0. Now we are moving on to the Schrödinger equation for a helium atom. In the case of a helium atom, the Schrödinger equation minus h cross square by 2m into del square minus h cross square by 2me del 1 square minus h cross square by 2me del 2 square into psi of r1 r2 plus minus 2e square by 4 pi epsilon naught r minus r1 minus 2e square by 4 pi epsilon naught r minus r2 plus e square by 4 pi epsilon naught r1 minus r2 into psi r r1 r2 is equal to e psi r r1 r2. It is the first equation where R is the position of the helium nucleus, R1 and R2 are the positions of the two electrons, M is the mass of the nucleus and Me is the mass of the electronic mass, and del square, it is a Laplacian operator with respect to the position of the electronic coordinates. Since here we are considering the 3-body problem and not a 2-body problem, so the mass separation into the center of mass and the relative coordinate will be much more complicated than in the case of hydrogen, because M is much greater than Me. However, regarding the nucleus, it is fixed relative to the motion of electrons. It is still an excellent approximation, which is given by the second equation, that is minus h cross square by 2Me into del 1 square plus del 2 square psi r1 r2 minus 2e square by 4 pi epsilon naught 1 by r1 plus 1 by r2 psi r1 r2 plus e square by 4 pi epsilon naught r1 minus r2 epsilon psi r1 r2 is equal to e psi r1 r2. This is the Schrödinger equation for the helium atom, and in this equation we can see the term e square by 4 pi epsilon naught r1 minus r2. It is the inter-electronic repulsion term. Now let us look how to convert a 2-body problem into a 1-body problem. As you can see in this picture, it is a 2 particles of mass m1 and m2 is considered, having the position vectors r1 vector and r2 vector respectively at any time t with respect to its origin O. Here r is a center of mass position vector, that is given by r cap is equal to m1 r1 cap r1 vector plus m2 r2 vector by m1 plus m2. It is the first equation. And for the center of mass position vector origin O is coincided, so r vector is equal to 0, which gives is equal to m1 r1 vector plus m2 r2 vector by m1 plus m2. So the second equation becomes m1 r1 vector plus m2 r2 vector equal to 0. Now by rearranging the equation in order to get the terms in terms of r, r1 and r2, we are writing it as r vector is equal to r1 vector minus r2 vector, and r2 vector is equal to r1 vector plus r vector. r1 vector is equal to r2 vector minus r vector. This is equation 3. Now using Lagrangian polynomials, we get that L is equal to T minus V, where T is the kinetic energy and V is the potential energy. L is equal to half mr dot square plus half m1 r1 dot square plus half m2 r2 dot square minus V, which is equation 4. Now using the equation 2 and 3 we can get that m1 r1 vector plus m2 of r2 vector plus r vector is equal to 0. On solving this for r1 vector we can get the value of r1 vector as minus m2 r vector by m1 plus m2, that is r1 dot vector is equal to minus m2 r dot vector by m1 plus m2, which is written as the equation 5. Similarly, we can solve the same for r2 vector also, which is given by, on solving we will get that value of r2 vector is equal to m1 r vector by m1 plus m2, that is r2 dot vector is equal to m1 r dot vector by m1 plus m2. It is equation 6. Now we are substituting the values of the r1 and r2 dot vectors into the fourth equation to obtain L is equal to 1 by 2 m1 r1 dot square plus 1 by 2 m2 r2 dot square minus v. As we have already seen, the half mr dot square terms becomes 0. So on solving this equation we finally get the value of L as L is equal to 1 by 2 mu r square minus v as written in equation 7. Here mu, it is the reduced mass which is given by m1 plus m2 by m1 plus m2. Which is now the two body problem, it is reduced to one body problem where L is equal to half mr square minus L, that is L is equal to 1 by 2 mu r square minus v. Now let us look to the separation of the radial and angular parts. In the Schrödinger equation of the hydrogen atom in polar coordinates, it is given by minus h cross square by 2 mu by into 1 by r square dou by dou r into r square dou psi by dou r plus 1 by r square sin theta dou by dou theta sin theta dou psi by dou theta plus 1 by r square sin square theta dou square sin by dou phi square minus z e square by 4 pi epsilon naught r psi equal to e psi. Here, as you can see, in both the LHS and RHS, it contains a term which is in linear into the side terms. So we are combining it and writing it as the equation given below, that is 1 by r square dou by dou r into r square dou psi by dou r plus 1 by r square sin theta dou by dou theta sin theta dou psi by dou theta plus 1 by r square sin square theta dou square psi by dou phi square plus 2 mu in by h cross square into e plus z e square by 4 pi epsilon naught r into psi equal to 0. Now, using the separation of variables, we are assuming that the product solution of radial and an angular function, that is given by the psi of r theta phi is equal to r of r into y theta phi. Here, since y does not depend on r, we can move it in front of the radial derivative and can be written as dou psi by dou r. It is equal to dou by dou r, ry is equal to y into dou r by dr by dr. And similarly, here r does not depends on the angular variables. So we can replace this psi and the differentials to write y by r square into d by dr, r square dr by dr plus r by r square sin theta dou by dou theta sin theta into dou y by dou theta plus r by r square sin square theta dou square y by dou phi square plus 2 mu by h cross square e plus z e square by 4 pi epsilon naught r into ry equal to 0. Now to this equation we are multiplying it by r square and dividing by ry in order to separate the radial and angular terms. We will be doing, after doing this we will be getting the equation as 1 by r into d by dr into r square dr by dr plus 1 by y sin theta dou by dou theta sin theta dou y by dou theta plus 1 by y sine square theta dou square y by dou phi square plus 2 mu r square by h cross square into e plus ze square by 4 pi epsilon naught r, that is equal to 0. Here as you can see, the first and fourth terms it depends only on r, and the middle term it depends only on the angles. So they can be balanced each other for all the points in space only if the radial and angular terms they are having the same constants but with the opposite sign. Therefore, now on separating the radial equation, we will get the radial equation as d by dr into r square dr by dr plus 2 mu r square by h cross square into e plus ze square by 4 pi epsilon naught r into r minus ar equal to 0. And angular equation can be separated and written as 1 by sine theta into dou by dou theta sin theta dou y by dou theta plus 1 by sine square theta dou square y by dou phi square plus ay equal to 0. As you can see, in both the terms, a term is coming. It is a separation constant. Thank you.